Welcome to Section 5, Risk Management Tools and Techniques. Click Begin to get started. As you have learned in the previous section, when adopted well, the risk management process offers significant benefits for built environment project professionals and stakeholders. In addition to the rigor that a risk management process provides, there are a variety of risk-related tools and techniques that can be adopted by project professionals. We will describe a few of these in this section. No one method or tool is perfect, and all have benefits and drawbacks. By selecting the most suitable tools and using them in combination with risk management processes and governance, the overall risk for your project is reduced, and better budget and schedule management is achieved. In this section, you will learn about how to use the Integrated Project Risk Assessment, or IPRA, tool to improve how risk is managed on built environment projects. Applying other risk management tools and techniques on built environment projects to drive a better risk process. For example, tools such as Monte Carlo simulations, probabilistic risk management techniques, and risk registers. Click Next to continue. The recognition of risk has been an age-old challenge, and based on research, there are known instances of historic risk analysis and management taking place in the Tigris-Euphrates Valley of Mesopotamia as early as 3200 BC. A people called the Asipu, who are considered to be the modern-day equivalent of risk management consultants, provided their services to clients by assessing risk and uncertainty for a variety of difficult decisions for which their clients were seeking answers. The issues that the Asipu would typically need to assess the risk of included anything from decisions regarding risking new ventures, proposed marriage arrangements, and selecting suitable building sites. This goes to demonstrate that our understanding of risk management methods and techniques have evolved for centuries. Notable technological advancements over the past 3 centuries have been made possible due to the 4 industrial revolutions, which include the discovery and wide adoption of coal and gas, modern electricity, computer electronics, and the Internet has transformed the entire landscape of the modern world. As a result, the associated complexity and scale of change has heightened the need and focus on risk management. In more recent times, there has been a greater emphasis placed on the formalization and standardization of risk identification, analysis, and holistic risk management to help make it more manageable, or at the very least, somewhat more predictable. Click the link to download a handy guide describing some key risk management terminology. Earlier in this course, you learned that a recognized way to visualize risks and understand their impact and likelihood of occurrence for your project is to use a risk assessment matrix. Having this understanding of the high, medium, and low priority risks is essential. However, equally important is matching appropriate mitigations that are suitable and realistically available to the project team when deciding on the most appropriate treatment for risks in the risk assessment matrix and risk register. Mitigation treatments that can commonly be deployed and documented in the risk mitigation plan for the project commonly include risk avoidance, risk retention or acceptance, risk control or reduction, risk transfer or deflection, and contingency. We'll review each of these risk mitigation types in the screens that follow. Risk avoidance is used as a mitigation method when a risk is not accepted by a project entity and they wish to not accept it. They would therefore consider a suitable mitigation for the scale of the perceived risk. Risk retention or acceptance is used when a conscious decision is made to accept the consequences should the event occur. The potential cost and schedule impact of the event may be estimated and allowed for in the project budget and schedule. Any contingency funds or reserves may also be set aside as a risk fund and linked to change control governance to ensure rigorous project contingency, transparency, and control. Alternatively, for low priority and low likelihood risks, the project team may decide to only monitor the event and act if the event occurs. Risk control or reduction is an active measure that is used when a process is needed for continually monitoring and correcting the events, issues, and conditions. This process involves first developing a risk reduction plan and then tracking its progress for specific risks. This mitigation strategy is the most common risk management technique. However, project professionals need to be cautious and not fall into adopting it as the de facto mitigation. Use of the risk assessment matrix is key to retaining perspective. As an example, this mitigation may be applied in an international project where the use of currency hedging is the agreed means to mitigate risk associated with external currency and exchange rate fluctuations. Risk transfer or deflection is used when the risk is shared with others and is a common mitigation that owner organizations adopt when setting up their projects. As an example, the use of a general contractor is a form of risk transfer. Other forms of sharing the risk with others include the following: contractual shifting, entering into joint ventures, securing multiple project funding sources, establishing performance incentives, and obtaining insurance, warranties, and bonds. Projects mitigating risk through contract language should hold to the principle that each risk should be given to the party that is best able to control it. Contingency as a standalone strategy should typically be the last resort, and it should give way to other strategies as information becomes available. Budgeting additional time or money to compensate for risk uncertainty is one form of contingency. On many projects, contingency will be used in conjunction with one or more other mitigation strategies. For instance, if a project team estimates a range of possible outcomes along with cost and schedule impacts, it can retain the risk by setting aside funds to handle consequences that may occur. In some cases, contingency is added to handle unknown unknowns as a standalone strategy. This is particularly true when limited information is available early in the venture. Best practice suggests that detail is needed to calculate contingency, whether it is based on uncertainty in the estimate or on specific discrete risk events. Such contingency amounts are based on bottom-up assessments by project teams. Any top-down contingency analysis should therefore include these kinds of rigorous bottom-up assessments to ensure they can include realistic management review and agreements that are based on experience as well as quantifiable facts. Simply put, contingency can be used to address the following risk scenarios. 1. There is a known lack of risk clarity or definition. For example, the degree of incompleteness of design at the time of estimating and scheduling. 2. Allowance needs to be made for identified risks for which the cost or schedule mitigation cannot be reliably established, or for which the mitigation strategies and their effectiveness are not clear. 3. There is a need for an allowance to account for known risks, which can be the outcome of a probabilistic evaluation using an approach such as the Monte Carlo methodology. And 4. Where there are unknown risks that the team is aware of but cannot identify and thus cannot account for them. When allocating project risks and considering their mitigation treatments, project teams often do not achieve the best risk allocation because of the inferior bargaining position of parties in the lower tiers of a project during contract negotiation. For example, those risks assigned to subcontractors as part of scope and contracts. In addition, the most appropriate and equitable allocation of a risk item varies by project and is heavily influenced by factors that include the type of risk, the work, and the contract terms that are often agreed during front-end planning, or FEP, during which subcontractors may not always have complete involvement. Finally, the chosen delivery model for a project plays a big part in the allocation, mitigation, and management of risk. Although there is no secret formula for arriving at a conclusive recommendation on risk allocation between contracting parties, the list of principles compiled by the Construction Industry Institute, or CII, can act as a guide when considering how risk is allocated. Click on the link to download the PDF guide. To read about a real-world project where risk allocation played an important part, refer to the Risk Allocation Case Study for Heathrow Airport Terminal 5, UK, in the Further Reading section of this course. Mitigating risk by reducing the likelihood of occurrence or lessening impact, or both, is a critical component of risk management. Implemented correctly, a successful risk mitigation strategy should reduce adverse impacts. In essence, a well-planned and properly administered risk mitigation strategy effectively replaces uncertain and volatile events with more predictable or controlled responses. Risk mitigation is therefore a continuous process and should be applied to all phases of the project. Project professionals and project managers have a wide selection of risk management methods, tools, and techniques available when analyzing and managing risk on their projects. Although not all methods are as broad and comprehensive as the CII Integrated Project Risk Assessment Method, the following methods, tools, and techniques can be tailored for use by the project to fit their specific risk management needs. They include, but are not limited to, documentation reviews and experience interviews, brainstorming and facilitation workshops, risk registers, Monte Carlo simulations, and the Delphi technique. Click Next. Project documentation such as contracts, design documents, project plans, and risk categorization checklists are a good source of project knowledge. They contain much of what a project team would need to understand the project context, requirements, and many of the associated risks that need to be analyzed and tracked. Poor documentation of any project is considered to be an issue that would need remediation and also highlights the importance of the use of Project Management Information Systems, or PMIS. A PMIS provides collaboration and documentation management functionality that reduces the need for paper, manual processing, documentation requests or approvals, and speeds up communication and decision-making. Using experience-based interviews helps identify risks through the interviewing of project professionals and obtaining information from experienced experts based on their past industry experiences. It is vital that the knowledge-based information attained must be appropriate and applicable to the current built environment project. Collaboration and knowledge sharing is a key part of risk management and can be achieved using various techniques. Similar to experience-based interviews, brainstorming is a commonly used technique in risk identification and brings together all relevant parties in the construction project to identify possible risks that might affect the project. The main purpose of this technique is to provide a free and open approach that encourages everyone on a project team to generate a list of potential project risks. This technique encourages risk identification in a manner that is non-critical and does not seek to attribute blame. In order to make the brainstorming session effective, the sessions must include individuals who have vast knowledge, experience, and expertise in risk management, especially within built environment projects. Conducting facilitated risk workshops is a common approach to gathering input for the Monte Carlo or Delphi techniques. Workshops help reduce the potential biases of individual participants, though facilitators need to avoid the potential for groupthink. In the workshops, a team of subject matter experts, or SMEs, reviews the project risk profile and uses their insight and expertise to discuss the level of uncertainty of each risk. If a project is not large or complex enough to warrant the level of effort required for a full workshop, experienced project management personnel can develop a reasonable risk-based estimate with individual input from project team members. Risk registers are synonymous with project management. A risk register is a document or spreadsheet that helps track risks throughout the entire project lifecycle. The document details all identified risks, including description, cause, likelihood of occurrence, relative impact or impacts on objectives, proposed mitigation actions, responsible parties, and current status of risks. The graphic shown depicts an example of an IPRA risk register, and the following steps should be used to complete it. Users enter identifying details of the risk into columns 1 and 2. In this example, the entries come directly from the IPRA assessment and should include a unique identifier and a risk event description. The results from the IPRA evaluation should be entered into columns 3 and 4 using the calibrated scoring as agreed by the project. In this case, the likelihood of occurrence is at level 4. Therefore, it has a high chance of occurrence, estimated between 65 and 90% by the team, and its relative impact rating, D, indicates that the issue can have significant consequences to the project. Column 5 requires an estimate of the specific potential impact to the project in terms of cost, schedule, scope, and quality. This will require further analysis and discussions, often using a bottom-up approach that enables a quantifiable and evidence-based value. Once the event or issue is identified as critical due to the likelihood of occurrence and/or the relative potential impact to the project team should identify and follow up on a mitigation strategy and/or action specified in column 6 to mitigate it. Several actions or strategies may be identified, studied, and documented for each of the items entered in columns 2 and/or 5. Additional analyses using probabilistic methods may be warranted as well. In column 7, an estimate of the cost of the action relative to the total installed cost of the project, high, medium, or low, or an estimated amount of currency should be entered, if available. In addition, column 8 asks for an estimated probability of success if the mitigation action is implemented. Best practice recommends that there should be a named person or owner for each risk and associated mitigation. Therefore, the person responsible for the action and the date of the next update or resolution should be entered in columns 9 and 10. Column 11 is for comments and status of the action. CII research has shown that Monte Carlo simulation is the most commonly used probabilistic approach to risk analysis on built environment projects. A Monte Carlo simulation begins with a deterministic project cost and/or schedule estimate, known as the base estimate, and adds multiple iterations of cost-time estimates for uncertainty and risk, known as the risk estimate. The result is a total estimate for cost and/or schedule that is presented as a range. Uncertainty can be modeled in terms of inputs for known items, including ranges of units, costs, durations, and other factors, and unknown items that include the risk events. Using a computational algorithm and specialist software, the Monte Carlo simulation runs hundreds or thousands of simulations, each time using a different set of values from the cost and duration risk model inputs. The 4 charts shown in the image illustrate probability distributions that are common to probabilistic analyses using Monte Carlo simulation techniques. The most advantageous probabilistic analyses are those that require a probability distribution for schedule and cost risks as an input. Generally accepted practices include the use of high or maximum, low or minimum, and expected or most likely values to make the 3-point estimates that are then applied to a triangular probability distribution. The Delphi technique is a multi-step method used to estimate future demand for a project and is beneficial when other methods are not adequate or appropriate for data collection. Built environment projects have scenarios with a common theme that revolves around schedule prediction and risk that ultimately means project stakeholders want to know how long it will take to completion and how confident are you in this date. The Delphi method is one technique that has been used on projects to address these 2 issues of time and risk. There are many variations of the Delphi technique, and the Delphi schedule risk assessment approach draws upon many of the same characteristics of the traditional Delphi technique with an application toward schedule prediction. This approach uses experts who are knowledgeable and experienced in the processes used to deliver the project to provide 3 different duration estimates: optimistic, most likely, and pessimistic. These estimates are provided on either a number of major milestones and tasks of the project or a high-level logic network of the project. They then each individually submit their estimates and assumptions to an analyst who reviews all the data received and issues a summary report. The quantitative output of the process is a cumulative probability distribution curve that shows the relationship between the probability of occurrence and the predicted schedule, in time duration or in a date. The process encourages the identification of potential barriers that influence the estimates. The summary report is then discussed and reviewed individually by the group members, who each submit revised forecasts to the analyst, who then reviews the material again and issues a secondary report. The application of this technique can create an environment in which the project team members can voice concerns and provide an opportunity for the project and functional managers to become involved in problem solving. This process continues until all participants reach a common ground. The concept of overall project risk has featured in project risk management guidelines for more than 2 decades, but adoption can still be a challenge for most project-based organizations. This is due to a variety of reasons, but often the root cause is that project teams concentrate on managing individual risks within their projects while not addressing the overall riskiness of their project. The selection of tools and techniques we have discussed are a useful way to assist the construction risk management process and enable the project team to focus more widely on implementing a comprehensive risk management approach. However, understanding the process is more vital than over-reliance on just tools, models, or systems. Therefore, when considering the costs of the software tools and use of techniques, their selection must be appropriate to the particular stages of the project, as some of them may only be suitable during the earlier stages, while others may be used later on. This has important implications not just for project success, but also for the management of risk at program, portfolio, and strategic levels. Let's take a moment to see what you've learned. Congratulations! You have now completed the Risk Management Tools and Techniques section. In the next section, you will learn about common causes of claims.